Hi, I'm Marnus, and this is my midterm project. It's a Django REST framework application which serves a catalog of machine learning models from the Hugging Face hub. I chose this dataset because I'm specializing in AI and machine learning, and it gave me real large-scale data. It gave me real large-scale data with natural relational structure. Every model has an author, task category, and license, which maps directly onto foreign keys. I initially considered the papers with code archive, but I rejected it because it's open, and its community-edited nature had let spam accumulate, while this dataset is programmatically generated and much cleaner. Okay, let's start from the zip file, as I will be submitting it, and let's extract it to my ready-made folder, video. There we go. All right, let's get started with creating the virtual environment. Okay. Oops, not that. Venv. Okay. There we go. That should almost be done. Then we can activate the virtual environment. That's it. Venv. Activate. There we go. Okay, the virtual environment is activated. Now we can install all of the requirements. Okay. So this installs Django 6.06, the Django REST framework, DRF Spectacular for the Swagger docs and requests, which is only used by the offline data collection script. Okay, this should be done at any moment. And next I'll be loading the data. We'll run the migrations in the loading script, but note that this already ships with db.sqlite 3 populated, but I'm gonna rerun it just to prove that it's idempotent and safe to rerun. So let's run the migrations. Migrate. There we go. Okay. Load data. Just load data. Okay. There we go. And that'll be done at any second. Okay, this command streams the models.csv row by row using get or create for the author, task, and license lookup tables, and it uses update or create for the model rows themselves, keyed on model ID. So running it twice never creates duplicates. It should be done very, very soon. Next, we will look at the unit tests. Alrighty, and we can see it was successful. Okay, let's run the unit tests. Python py test. And these are 13 test cases across 5 test classes using DRF's API test case, and a shared setup mixin that seeds 2 authors, 2 tasks, 2 licenses, and 2 models before each test. So we can see all 13 tests were successful. Alrighty, now we can go ahead and run the server. There we go. Let me copy the URL, open Chrome. Okay. As we can see, here is our landing page. This includes the interactive Swagger UI, with all of the endpoints included there. Here's all of the actual endpoints, and admin page root for login. It includes the Python and Django versions, it loads it dynamically, and my username and password. Okay, let's run through the first endpoint, which lists all the models, and you can optionally filter with task, license, and minimum downloads. There we go. That's that one. Next was the post version of this, and this is to create a new model entry. There it is. Okay, and next up, let's do the top authors. And this was the most complex query in the app. It annotates each author with a count of their models and a sum of their downloads across a reverse foreign key in a single query, rather than looping through every author in Python. Okay, and this is stats endpoint, which lists some stats. And let's lastly look at the summary. And this returns per task the model count, total downloads, and the single top model, which is useful for seeing which categories dominate each task. Okay, now let's look at the database design. I have 4 models: author, task, and license, which are lookup tables, and ML model, which is the fact table with foreign keys to all 3. I used cascade on author since a model is meaningless without one, but protect on task and license since those are stable classifications, and I don't want to have an accidental admin deletion wipe out thousands of rows. Okay, that covers the dataset, the endpoints, the tests, and the database design. Thank you so much for watching.